Hello friends, now we'll discuss about first law of thermodynamics. In order to state first law of thermodynamics and understand it, we must define the following terms. First of all, sign of work. Sign of work, that is W. Actually, when work is done by the system, mind it, work is done by the system, its sign is negative. Work done by the system. Work done by the system, the sign of work is negative. Very important. Work done by the system, the sign of work is negative. Work done on the system. Work done on the system, the sign is positive. Now, sign of heat, that is Q. When heat is absorbed by the system, the sign is positive. Heat, that is Q, is absorbed, the sign is positive. And when Q is released, the sign is negative. This sign concept of work and heat is very important to realize first law of thermodynamics. Now we define another important term, that is internal energy. Internal energy. Internal energy. Internal energy is represented by U, capital U, or capital E. What is the definition of internal energy? The energy possessed by a system by virtue of its existence is called internal energy. Let us consider with an example. A body like a pen is raised to a height of h centimeter. Then the pen will get some potential energy, and this potential energy is the internal energy of the pen at that state. Now we write some characteristics of U, that is internal energy. Number 1, it is an extensive property of the system. That means if mass of the system is high, its internal energy is also high. Number 2, its change, that is du, is a state function. What is state function? State function means the function which depends only on the initial state and final state, but not on the path of transformation, is called change in internal energy. Let us consider a system is present in A state. It is transferred to B state. Now in A state, its internal energy is UA. In B state, its internal energy is UB. So what will be the change in internal energy? That is du is equal to UB minus UA. UB minus UA. That is, it only depends on the initial state and final state. If the system goes from A to B through a third state C and then to B, from A to C, then to B, then the change will be same. That is, it is du and it is equal to UB minus UA. This is called state function. That means the function doesn't depend on the path of transformation. It only depends on the initial state and final state. Now, the statement of first law of thermodynamics. The first law of thermodynamics is nothing but the law of conservation of energy. That means the energy of the universe is constant. Energy neither be created nor be destroyed. Energy can only be transformed one form to another. This is first law of thermodynamics. Let us derive this law. We consider a system is present in A state and it is transformed to B state. In A state, the system has internal energy UA. Q amount of heat is supplied to the system and W amount of work is done by the system. As a result, the system goes to B state, and in B state, its internal energy is UB. Now, according to the law of conservation of energy, UA plus Q plus W, this is the total energy. UA is the energy present in A state, Q amount of heat is absorbed by the system, its sign is positive. W amount of work is done on the system, its sign is also positive. As a result, the system transforms from A to B, and in B state, its internal energy is UB. So we can write UB minus UA equal to Q plus W. Or UB minus UA means delta U, the change in internal energy. It is equal to Q plus W. This is the mathematical form of first law of thermodynamics. Mind it, Q is the heat absorbed by the system, W is the amount of work done on the system, and delta U is the change in internal energy. If the change is small, we can write du in place of delta U. du represents small change in internal energy. It is equal to dq plus dw. So du equal to dq plus dw. That's all about first law of thermodynamics. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.